Students should be involved in deciding how they want to represent their data, but they will need to be introduced to what options are and when each display can and cannot be used. Creating graphs requires care and precision, including determining appropriate scales and labels so that the audience is able to see at a glance the summary of the data that was collected. Instruction should not focus solely on details of the graph's construction. The focus must be on what graph tells the people who see it related to the question posed. An object graph uses the actual object being graphed, such as shoes, favorite apple, energy bar wrapper. Picture graphs move up a level abstraction by using a drawing or a picture of some sort that represents what is being graphed. Bar graphs are among the first ways used to group and present data with students. To help transition from picture graph to bar graphs, have students use something to represent the piece of data or the thing they're being counted. And the figure on the slide before illustrates a few techniques that can be used to make a graph quickly with the whole class. Once a graph has been constructed, engage in the class with a discussion of what information the graph tells or conveys. What can you tell me about our class by looking at the shoe graph right now, as an example. Pie charts and circle graph mean the same thing. The term circle graph may be more common, and the term pie charts is used with graphing tools such as electronic spreadsheets. Pie charts, like bar graphs, typically display category data. The figure on the right, for example, shows a pie chart for classroom data and school-wide data illustrated the percents of students with different numbers of siblings. They're easily constructed. Students can first form lines to respond to what is your favorite after-school activity, and then the lines can be joined in end-to-end to make a circle, as illustrated on the graph on the left. Stem and leaf plots, sometimes called stem plots, display numeric data as lists, groups within data ranges. If you look at the example down below in 11a, if the data are not grouped by tens, list the tens digit to form the stem. Next, write the ones digit next to the appropriate tens digit as shown in the figure 11b, ordered from smallest to largest from forming the leaves. The results show the shape of the data included where the data clusters and where the outliers are. Line plots are also called dot plots, are counts of things along a numeric scale on a number line. Later in middle school, the term dot plot replaces line plot. To make a line or a dot plot, a number line is drawn and an X or dot is made above the corresponding value of it on the line. For every corresponding data element, one advantage of a line dot is that every piece of data is shown. A histogram displays numeric data in a consecutive equal intervals. The number of data elements falling into that particular interval determines the height or the length of each bar. Histograms differ from the other bar graphs, which are used for category data, for which the order of the bars does not matter. The histogram effectively shows the distribution of data values, especially the shape of the distribution and many other values. Box plots, are also called box and whisker plots, are a method for visually displaying not all the centered median, but also the range and the spread of the data. Importantly, a box plot highlights the interquartile ranges, making visible the middle 50%, and to the left is 25%, and to the right is 25%. A box that contains the middle half of data, 1/4 to the left, 1 and right of the median. The ends of the boxes are the lower quartile, and the median of the lower half of the data, the upper quartile. The median of the upper half of the data. A line inside the box at the median of the data. A line, sometimes known as the whisker, extends from the end of each box to the lower extreme and the upper extreme of the data. Each line therefore covers the upper and lower fourths. A line graph, a coordinate axis, allows for the plotting of a bivariate numerical data. When data are continuous, a line connects the data points and illustrates the trend of the data. For example, a line graph might be used to show how the length of a flagpole shadow changed from 1 hour to the next during the day. Scatter plots Bivariate numerical data can be plotted on a scatter plot, a graph that points on a coordinate graph which each axis represents one of the two numeric variables. Each pair of numbers from the data, when plotted, produces a visual image of the data as well as a hint concerning any possible relationship. One way to help students analyze a scatter plot is to look at the vertical slice and consider what that means. For example, here you might gather 25 8th graders on their height in inches, weight in pounds, number of letters in their last name. A scatter plot of the weight versus height, and B, a scatter plot of the weight versus name length. Mean cost of games. Activity 20.12. Post a copy of the games cast. Have students make a bar graph of the data using connecting cubes, as illustrated in the left diagram. In the figure shows cubes stacked for price of each game. The task for students is to use the stacks of cubes to determine what the price would be if all games were the same. Balancing point interpretation. To illustrate, draw a number line on a board and arrange 8 sticky notes above the number 3, as in the figure above. Alternatively, you can use a stack of cubes. Each sticky note represents one family. The notes are positioned on the number line to indicate how many pets the family owns. Stacked like this indicates that all families have the same number of pets. A good way to illustrate balance is on a number line balance that is adapted to have values between 0 to 20 as in the figure. Notice that as one plastic piece data point is placed on the right, one more or more other data points must be placed on the left. Using this model, students instantly see if there is a balance because the balance otherwise physically tilts to one side. The next two activities, you can focus on this. 20.14 balancing cubes, 20.15 balancing sticky notes. Changes in the mean. The balance approach to finding the median clearly illustrates the difference between data distribution that can have on the same mean, especially for small points of data. The mean is specifically affected by extreme values. Therefore, the mean provides a representative value of the data, or the median, which is not sufficient for fully describing the distribution of the range of data.